Okay, today we're going to work on a second day of lesson 3.10, perpendiculars and distance. Yesterday, you remember we worked on finding the distance from a point to a line. That had a four-step algorithm where we had to write equations for the line and for the line perpendicular. Use those two to find the point of intersection that was perpendicular to the point off the line, and then calculate the distance using distance formula. Today's algorithm is a little bit different, but uses a lot of the same concepts as we try to find the distance between two parallel lines. Okay. All right. So the distance between parallel lines, by definition, parallel lines are lines in the same plane that do not intersect. Okay. You could also say that they are lines that are an equal distance apart. So two parallel lines remain an equal distance apart infinitely. Okay. No matter where you measure it, those two lines are the same distance apart. Remember also, parallel lines have the same slope. All right. The algorithm for finding the distance between parallel lines goes like this. Number one, we're going to write an equation for a line that's perpendicular to both lines, because if it's perpendicular to one, it's perpendicular to the other, and passes through one of their y-intercepts. Second, we're going to solve the system of equations. The new perpendicular line that we've written and the parallel line whose y-intercept we did not use, that calculation will tell us the point of intersection between our perpendicular line and the line we did not use. And then we're going to use that point of intersection and the original y-intercept to find the distance between the two lines. And it'll be more clear when I go through it. It's kind of vague right now. Let's take a look. All right, so we're supposed to find the distance between these two parallel lines, R and T, who have these equations respectively. All right, so if you look graphically, this graph, green, I think, is y equals negative 3x minus 5. It's going down here, and it's eventually going to cross the y-axis at negative 5. So that's that line. The graph of this line is y equals negative 3x plus 6. It's crossing the y-axis at positive 6. They both have a slope of negative 3, so they're parallel. Okay? So the first thing we got to understand is that we're going to write a new equation for a line that's perpendicular to both these lines. And we're going to borrow this y-intercept, because now we'll have one of the 2 points we need to find the distance given to us, because we know what this y-intercept is. So we can choose anywhere to put this line we want. So we're going to put it right here. All right. So this point we know is 0, 6. And we know that on this line, it's the y-intercept. Okay. So my new equation, this equation right here for this green line, is going to have the opposite reciprocal slope because it's perpendicular to these two. So its slope is 1/3. And we're going to pass through the point 0, 6. So that gives us a common point. Now I can go through the process, but really what happened is I just told you the y-intercept for the green line too. And I solved it and got the y-intercept to be 6. So our new green line equation here is y equals 1/3 x plus 6. Remember, guys, to find the distance between these two, we want to find points that are on the same perpendicular line between these two, and then we're going to find their distance. I have one point already. It's 0, 6. What I now need is this other point. All right. And to find the other point, we're going to take the new perpendicular line and the other line whose y-intercept we didn't use, and we're going to find out where these two intersect by solving those two as a system. So I'm going to take negative 3x minus 5, the equation for this line, and y equals 1/3 x plus 6, the equation for our new perpendicular. And I'm going to solve these two as a system. What that will do is tell me the point of intersection right here. All right, this is substitution. They're both equal to y, so they equal each other. I'm going to multiply everything by 3 to eliminate this denominator in this fraction. As long as everything gets multiplied by 3, it's equivalent. So distribute the 3 through the first parenthesis. We'll get x plus 18. Distribute the 3 here. We get negative 9x minus 15. Now I have a simple equation to solve that has no fractions in it. So I'll add 9x, subtract the 18. I'll get 10x equals negative 33. Divide each side by 10, and x equals negative 3.3. Okay, so I know I'm coming over negative 3.3 is the x coordinate for this point right here. Now, where is it on the y-axis? Well, take our negative 3.3 and plug it into either one of these two. Okay, I took the top equation. I'm going to put negative 3.3 in place of the x to find the y. Okay, 9.9 minus 5 is 4.9. So if you go up here, and these go up by twos, 4.9 is right in here. So yeah, that's the point of intersection, right? Our point of intersection for the other line and the perpendicular line is negative 3.3, 4.9. See, now I know that these 2 points are perpendicular to each other. They're on a perpendicular path to each other. And this will give me the distance between these 2 parallel lines. So we're going to take these 2 points and we're going to find the distance between them using distance formula. So 4.9 minus 6 quantity squared, negative 3.3 minus 0 quantity squared. Okay. And we'll wind up getting the square root of 12.1, which is about 3.5 units. So these 2 parallel lines are about 3.5 units apart from each other. Okay, a 3-step process. Let's take a look at another one. Okay, so if you notice, I wrote 1A here. This gives us a set of parallel lines, but it hasn't written them in slope-intercept form the way we like it. So we got some work to do here first. All right. So we want to take each of these 2 lines and write them in slope-intercept form first, which means we got to solve them for y. Okay, so we'll subtract x, we'll divide everything by 3, and that's the first one. Subtracts x, divide everything by 3. Here's our second equation. So now you can see they're parallel. They both have a slope of negative 1/3. They have 2 different y-intercepts. Our job is to find the distance between them. All right, so I'm going to write an equation now for a line that's perpendicular and passes through one of their y-intercepts. Okay, I'm gonna choose the easier one. So I'm going to choose this 2 as my y-intercept, and I'm going to take the opposite reciprocal of this. So the equation for the line perpendicular to these 2 lines going through this y-intercept is y equals 3x plus 2. Now we need to figure out so we know where these 2 intersect. They intersect at 0, 2. Now I got to figure out where these 2 intersect, right? And to do that, I got to solve the system. So again, we're going to set them equal to each other, and I would multiply everything by 3, go through your solving process. You're going to get -2, -4 to the solution to this. All right. Once we've done that, now it's time to find the distance. Remember, the 2 points we're going to find the distance between are the y-intercept that they share, 0, 2, and the point that they intersect along the other pair here, which is at -2, -4. We'll plug that into the distance formula, calculate it, and we're going to get square root of 40, which is about 6.32. All right, so we're going to have a few of these types of questions tonight where you're going through this process, solving to find the distance between the parallels. All right, we're going to go through it in class. You have this to use to hopefully to help you out if you need it. But we're going to work on these today. All right, I'll let you have it.